closely. Well, without much further delay, Revolutionaries from ITE College East will be here for the presentation. Give them a big round of applause, please. Welcome, guys. This is IPv6 U-Scan project. Judges, this falls in the category of IPv6 on-year content. And Revolutionaries, if you're ready, please take it away.
All right. Good morning, everyone. Judges, my name is Glenn. Today I'll be presenting you our business idea of using IPv6. Okay. So what I'm going to go through today is the introduction of my team, the visions of our idea in the future by using our idea, and then our idea, some of the observations, solutions, and lastly, the U-Scan devices, and a short video demonstration. So, Team Revolutionaries is made out of 5 students from ITE College East. Our project, U-Scan, is a business concept based on IPv6 that will revolutionize the whole retail industry. So the vision of our idea is to actually provide customers worldwide with a whole new shopping experience by using purchasing of products by using online and physical by using IPv6. It also opens up to a new industry and creates a synergy between the 3 current industries that we have: the logistics, retail industry, and also the e-commerce industry. We call this new industry Web industry. And don't forget to also to boost the labor productivity for organizations that actually adopt our idea. So what is our idea really? It's actually putting customers with a whole option in purchasing items as a combination of both physical and the online e-commerce store. By also adopting the big data to provide a statistical analysis of product demand worldwide. And also in the process, we like to reduce the commercial rental cost needed for our stores to set up. So some of the observations that we have. The main pressing issues that have to be addressed in the retail industry are the escalating commercial rental costs, low labor productivity, and some of the securities and accidents. So let me talk about labor productivity. Recent statistics have shown that within the last 3 years, there has been a drop of average 30% of the labor productivity. As for the rental cost, Singapore is a small metropolitan city of 704 kilometers square. It's a population of 5.3 million currently. The government has also recently announced that by 2030, Singapore will have an estimated population of 6.9 million. So in order to actually cater for such growing population, housing development is unavoidable. Therefore, escalating rental costs will also probably be unavoidable as commercial space will be much lesser due to the fact that housing development will be using the spaces. As you can see on the chart, we have a recent statistics also showing that rental costs has been uptrending within the last 7 years. Now again with the security and accidents. Some of the issues that we face in departmental stores, some of the stores are product theft, accidental product damage, customers injuries from carrying faulty items. So let me now talk about the solutions. For labor productivity, by adopting our solution in this industry by providing RESTCOM industry, it opens up a whole new revolutionary platform in the retail industry. Increase the productivity of each labor to be much leaner headcount to actually manage each store much more efficiently. For the rental costs, in the future we have a much more compact shelving so that not all products will have to be placed onto the shelf. Therefore, lesser space will be needed, which ensures the lesser rental cost for the store owners. For security and accidents, we have product theft. So, like I said, the future stores, all we have to do is just a compact shelving to display a certain product, for example, just a sample product, for example. How much can a product sales actually spill? There's only a sample product there. You can't actually spill. There's a limit that you can spill there. For accidental product damage, so what is accidental product damage? For example, you pour a can of soda, and then it's accidentally someone will bump into you, drop the can of soda on the floor, and then it gets dented. Who would like to buy it? No one would like to buy it. So actually to prevent this, all we have to do is just a sample product, so that the product that will be damaged is much lesser, is significantly lesser. As for the customer accidental injuries, you don't have to carry such bulky items. So for example, you went to IKEA in the shop, let's say you bought a DIY furniture that you want to actually assemble when you're home. So how are you going to carry this back home if you don't have a car? Because I can't afford a car. So all you have the option is actually take a cab or actually take the public transport. As you know that public transport in Singapore is very crowded. So you actually risk yourself actually injuring yourself, damaging the product, or actually injure people around you. So by actually avoiding all these problems, we actually remove the whole idea of actually purchasing the item and bringing the item back to home by yourself. So what are the benefits of the idea that you actually gain from actually adopting our idea? You have lesser shop space, you don't have to pay that much of a rental cost, you have a much more linear headcount to have them work much more efficiently as the same efficient that you have now in the present. And you have a real-time monitoring of analyze of the inventory and the market demand. And also, lastly, we're actually lowering down the cost of living due to the fact that rental cost has been reduced, staff have been reduced, and work much more efficiently. So right now, this is the system prospect, where I'm going to pass my mic to Hao and Lambert. They'll actually explain to you more about the packet flow and also the data flow of how the whole idea works.
Okay, so now I'll talk about the system perspective. Here, this here is the main server, the warehouse server. This server controls data flow between all these shop servers and other servers. Okay, this here is the query for information. How we look for information or get information from other servers. First, we'll be using a reader to tap the NFC tag. And by tapping NFC tag, we'll get an NDEF record. This NDEF record will then be changed by the reader into an IPv6 packet, which will then be used to ping either one of these three servers. And these three servers in reader will return us information packet. This is the code for delivery. As the same as the last slide, but there's one difference here. The difference is the IPv6 packet doesn't go to either one of these areas, but instead goes directly to the warehouse. From the warehouse, this packet will then be sent to the distributor and manufacturer to update their records at real time. At the same time, one packet will be sent to a delivery team to pick up the product and be sent to the user.
So, this will be the data flow of the whole IPv6 packet, how the data will be flowed. First, the user will use the use-scan devices to scan on the NFC tag of the product. And when they scan, they will get the information that will be captured into an IPv6 packet. This IPv6 packet will be sent from the warehouse server to the distributor server, and from the distributor server to the manufacturer server. So, scanning of the NFC tag. User will use the use-scan devices to scan on the NFC tag right beside the price tag, which is the red arrow is pointing. And in this NFC tag, there will be three information. The product IPv6, which is the product item code, and the distributor IPv6 address, and the manufacturer IPv6 address. These three information will then capture into an IPv6 packet. So, on the screen, it will be roughly how the IPv6 packet will look like. The source destination, the source address will be the use-scan device, and the destination address will be the warehouse IPv6 address. Destination authenticator, it will contain the manufacturer IPv6, distributor IPv6, and the product, and also the number of quantities you want, which is so-called the NFC record. This packet will then be sent to the warehouse server. When the packet reaches the warehouse server, the source address will be changed to the warehouse IPv6 address. The destination will be changed. Distributor IPv6 to plus the product IPv6 address. And there is this hybrid routing destination header, which will be the manufacturer IPv6 subnets and also the product IPv6 address. And also the NFC records, which is said earlier. This address, this packet will be sent to the distributor server. When the packet reaches the distributor server, the destination address will be changed from the distributor IPv6 to the manufacturer IPv6 address. And after this, the packet will then send to the manufacturer server. So, for the customer perspective, the customer will first use their devices, the same thing, scan an NFC tag, and they will pay using the applications, which is so-called the Visa or credit cards orders. Then the product will be delivered on the real time as the order. So they deliver to the customer's house, and the customer will be very happy to receive the product, as they don't need to carry home so easily. So for the use case devices, the external, we will let the landlord to say about this.
Okay, this is a unique device, a futuristic device that we have created. So right now it's still an uncolored model, but we have an idea of how it works and how it's like. Up here, this is where the power button is at. This power button allows you to on and off the device, so it saves electricity. Over here, this screen, this LCD screen and button is where you select your quantity after tapping the device onto the NFC tag. Here is where we charge the battery. For the battery, we are thinking of using a new technology that allows the battery to be charged up within 3 minutes, so that it doesn't waste any time at all. Here, this part is the most special part of this device. It's a flexible touch screen that can be pulled out and pulled back in whenever you need to. This device is created in the shape of a cylinder because cylinders do not just drop on the floor and break. They actually bounce back a bit. So it increases the durability of this device. Okay, now I'll pass the mic to Keith.
I will now present to you about our prototype phone application. User will now log in using a user ID and password. After keying in the user ID and password, press the login button. After logging into this is the menu page. User will see a different type of options such as shop deal, shop now, video, and etc. User will now press the Shop Now button to continue the shopping. Shopping page. To scan the NFC tag using the devices to shop for the item. After capturing the product, it will be displayed to the user. After that, user will be selecting the quantity of the item. After selecting and confirming, press the Add to Cart button. After user has finished the shopping, user need to exit the page by pressing the Home button. To view the shopping cart, user will now press the shopping cart button. This is the cart item cart page where user will check for their information, example, their item and their product, whether it's the product that they wanted, and press the confirm button to confirm their checkout page where user will key in their delivery address and card details and press the confirm button after you have checked everything. After the checkout page, customer will be able to see a thank you for shopping page which indicate that orders have been placed successfully. And to end this shopping experience, press the done button. Now show a demonstration video for shop one.
here, we have a NFC IPv6 enabled shop. Looks like our customer found something they like. In order for customers to purchase this tin of chocolate, they will need to first log into the application. Then, press the Shop Now button to proceed with the shop scanning of the NFC tags right beside the price tag. Right after scanning the tag, it will display the product information, then customers will select the quantity. In order for the customers to select more items, they will just have to repeat the process of scanning the tags. Once customers have finished shopping, they will press on the home button to return to the menu page. Customers will now have to press on the shopping cart button to verify the items selected. Right after verifying all the items, customers will need to press onto the confirm button to enter the payment information. Press on the confirm button again to end the session. Right after everything, customers can now await the items to be delivered. Right, so that's all for our presentation. So now we would like to answer your questions.
The Revolutionaries, give them a big one of applause, please. Not bad. Doing something that we all Singaporeans like, shopping online. Seems to be a very simple interface to use, something easy. To our judges with some burning questions or clarification, may we please invite you at this juncture to pose your questions, please, for the Revolutionaries.
Do you have a prototype running of the routing that you guys are doing with IPv6?
As for routing and all testing, we actually not design and test it because it's just a business concept. So we still have a own application that we actually did for the business side of the
Okay.
Are you able to explain why IPv6 is required for this project?
So in the future, right, all will have their own IPv6 address instead of using the barcodes. So by using the barcodes, you have a duplicates, and then they might have some duplicates out in the world. So by using IPv6 address, we have the extra address space that we use just for the products, for the manufacturing and communications instead. So it's just to actually prevent the duplicates by using barcodes. And so by using IPv6 address, it usually sends to the manufacturer and distributor to have real-time monitoring of the market demand and see whether you need to have restock for the stores and whether the product is needed to be restocked out in the stores or which region you need and which item is in the market demand to have it profitable. It's therefore to send information like we have in the previous slide that explains that the reader sends 3 packets to the manufacturer, to the distributor, and to the warehouse.
It's more of a comment. So this current application already exists, but with proprietary solutions. So what you are introducing is an open standard that allows not only to do it for a single chain, but you can do it in multiple chains, and even invite all kinds of distributors, to have a full distribution chain. It's not even to go to the source of the food or whatever products. So you can even do it, for instance, for the cooling system, that you can see whether the cool system has not been broken, in order to see whether the food is still fresh. Because most of the time, this is where products fail and their value depreciates quite a bit. The only concern I have is you have to check on the addressing scheme or the address plan, how it is done in a way that it is fairly well managed and so on. But I think the concept is very, very important. And I think it will be deployed by companies like Amazon in the future. The beauty that we are adding to it is that it's a combination between Amazon and live shopping directly. You can see things for yourself, because you can do that for food and so on. You want to see the quality as well. Thank you very much for at least for the good content.
Thank you.
That is certainly changed our shopping experience. Right. I'm just curious, further to what Dr. Latif said, is about the addressing scheme. Well, how are you going to get the addresses tagged? Imagine if you try to apply it to any items, right? Whether it's clothes or whatever items, right? How to get it tagged, and have you thought about that yet?
For the address, right, there is 128 bits. So for the first 64 bits will be for the manufacturer, distributor, and the warehouse. And for the next 64 bits will be for the products. So the product will have a 64 bits of range of address, which is a lot. So every product will have one address. Yeah. So all different type of products also can be used.
I don't think that's the way it would work, because the first 64 after the prefix given to you by the operators. So all what you are left with is the next 64.
Yeah.
So the only address space that's left in order to work with the RFID, whatever you have, is whether you compress the very long RFID addressing into the 64. So you cannot use these 264 the way you want.
I would say that the first 64 bits, there will be used up, but the kind of the first 64 bits, there will still be some spaces. So we will like use it for one of the location ways, or distribution, or one of the location will be for the manufacturer.
No, I think you need to rethink the addressing scheme, because the first 64 you cannot touch. That's used in order to route the traffic to the ISP that you are using. So the only space that you can use is the next 64 bits. And that's normally it's a MAC address, but you can change it. You can do with it whatever you want. So you can replace it with RFID. So you need to rethink your addressing scheme. But that's not really a problem, because obviously in the real life, somebody will tell you, okay, don't touch the first 64, but the next 64 you can do with it whatever you want. So it will work. Okay, you just have to. The addressing scheme in IPv6 is very complex, so you have to know the rules.
Wise words indeed. It's once again very encouraging. We'd like to thank our judges for also their sound advice as well. Let's give the Revolutionaries once again a big round of applause. Good job, guys. Thank you so much. The Ventures from NTU School of Tripoli.